The James Webb Space Telescope found something that should not exist. A structure so massive, so ancient, it predates the universe itself. And the moment scientists ran the numbers, they went quiet. By the end of this video, you'll understand exactly what JWST found, why it breaks our entire model of how the universe was born, and what it means that our best theories might be catastrophically wrong. To understand why this discovery is so catastrophic, you first need to understand the story we told ourselves about how the universe began. 13.8 billion years ago, everything, every atom, every galaxy, every law of physics exploded from a single point: the Big Bang. In the first few 100 million years, things were simple. The universe was a hot, dense fog of hydrogen and helium. No stars yet, no galaxies, just particles, slowly cooling, slowly drifting. Then gravity got to work. Those particles began to clump. The first stars ignited. Then small galaxies formed. Then, over billions of years, those small galaxies collided and merged into the massive structures we see today. It's a process called hierarchical structure formation, and it has a speed limit, because the universe is not just expanding, it's expanding at a specific rate, the Hubble constant. And that rate tells us how fast matter could have traveled, how fast gravity could have pulled things together, and, crucially, how large any cosmic structure could possibly be at any given moment in cosmic history. This isn't just a theory. It's backed by 60 years of observations, computer simulations, and mathematics so precise that physicists bet careers on it. The lambda CDM model, cold dark matter cosmology, is the foundation of modern astrophysics. It had one rule above all others: you cannot build something enormous in almost no time. When the James Webb Space Telescope launched on Christmas Day 2021, scientists were excited but measured. They expected to see the early universe the way the models predicted: young, raw, disorganized, patches of proto-galaxies, faint, irregular blobs of early star formation. What they got was nothing like that. Within months of its first deep-field images, JWST began returning pictures of galaxies that were too bright, too massive, too structured, far too early in cosmic history, galaxies that looked like mature, fully formed spirals existing just 300 or 400 million years after the Big Bang. Galaxies that, by every calculation, should not have had enough time to become what they were. Astronomers called them impossible galaxies. Peer-reviewed papers used that exact word, not metaphorically, technically impossible, within our current model. But that was just the opening act, because as the data kept coming in, something even stranger began to emerge from the noise. Researchers studying JWST's deep field surveys noticed that certain galaxies weren't just large on their own. They appeared to be connected, aligned, distributed across space in a pattern that had geometry. And when they mapped it out, the scale stopped them cold. Let me give you a sense of scale before we go further, because the human brain is genuinely not built to process what we're about to talk about. The Milky Way galaxy, your home, containing 400 billion stars, is roughly 100,000 light-years across. If you scaled that down so 1 light-year equaled 1 millimeter, the Milky Way would be the size of a football field. The observable universe, at that same scale, would be about the distance from Earth to the Moon now. In that context, the largest confirmed structure in the known universe, before JWST started complicating things, was something called the Hercules Corona Borealis Great Wall, discovered in 2013. It spans approximately 10 billion light-years. At our scale model, that's roughly 1/3 the distance from Earth to the Moon. 10 billion light-years. Cosmologists were already uncomfortable with that one, because at that size, it already nudged against the theoretical limit of how large a structure can grow given the age of the universe. It was borderline, suspicious. And then JWST started mapping what sits at the edge of our observable horizon. Here's where things get genuinely strange. Researchers analyzing data from JWST's early universe surveys identified a concentration of galaxies, a superstructure, existing at redshift values that place it approximately 11 billion light-years away. Meaning we're seeing it as it existed 11 billion years ago, when the universe was less than 3 billion years old. And the preliminary size estimates for this structure exceed what the lambda CDM model says is physically possible by a factor of several orders of magnitude. Let that land. This isn't slightly off. This isn't a rounding error or a calibration issue. If the measurements hold, and multiple independent teams are now working to verify them. This structure is not just large. It is impossibly large for the time it exists in. It would require the universe to have built something enormous in a fraction of the time our models allow. Which means one of two things. Either there is a systematic error hiding somewhere in the data, or the universe is older and stranger than we ever imagined. But before we get to what that actually means for physics, you need to understand something even stranger about what JWST has been finding hiding in plain sight. Cosmologists have a term for the boundary of what we can observe: the cosmic horizon. It's not a wall. It's a limit imposed by light speed and time. Everything beyond it is invisible to us, not because there's nothing there, but because the light from those regions hasn't reached us yet. JWST is peering as close to that horizon as any instrument ever has. And what the data suggests is that the large-scale structure of the universe, the arrangement of galaxy filaments, voids, walls, becomes increasingly non-random as you approach that edge. Non-random, meaning organized. Organized beyond what random physical processes should produce, and a small but serious group of cosmologists are now asking a question that would have ended careers 10 years ago. What if the universe didn't start from chaos? Here is what the evidence is forcing serious physicists to consider. Right now, if structures exist in the early universe that are too large, too organized, too mature, there are only a small number of explanations that survive mathematical scrutiny. The first, our measurement of the universe's age is wrong. The Hubble constant, that fundamental expansion rate, has actually been in crisis for years. Two completely different measurement methods keep returning slightly different numbers. It's called the Hubble tension. And if the real expansion rate is different from what we calculated, the universe could be significantly older than 13.8 billion years. Old enough, perhaps, for these structures to make sense. The second possibility is more radical. The physics of the very early universe, the first fractions of a second after the Big Bang, may have operated under different rules than we currently model. A phase called cosmic inflation is supposed to explain the large-scale smoothness of the universe, but inflation models vary wildly. Some versions of inflation allow for pre-existing structure, geometry that survived the bang itself. The third possibility is the one that almost no one wants to say out loud. That the Big Bang was not the beginning. That our universe emerged from something else, a prior state, a collapse, a cycle, and that what JWST is seeing at the edge of our horizon are the fossilized fingerprints of whatever came before. Bouncing cosmology, cyclic universe models, pre-Big Bang structure. These are not fringe ideas. They are published, peer-reviewed theoretical frameworks sitting in the back of the room, quietly raising their hands. JWST may have just called on them. You might be wondering why any of this matters beyond the abstract. Here's why it should keep you up at night. In the best possible way. Every technology you use, every satellite, every GPS signal, every prediction of solar behavior that protects power grids, all of it runs on physics models that trace back to our understanding of cosmology. When the foundation shakes, the implications ripple forward into everything. More personally, every culture, every religion, every philosophy that has ever tried to answer, where did all this come from, has been working with the same assumption, that there was a beginning. JWST is holding up data that asks, with genuine scientific seriousness, what if there wasn't? What if the universe has no origin story? What if it has always, in some form, been here? That question is no longer poetry. It is now a legitimate scientific hypothesis supported by observational evidence. The James Webb Space Telescope was built to show us the first light of the universe. Instead, it may have shown us that the universe has no first light, that what we called the beginning was merely a transition, and that the cosmos, ancient, vast, structured beyond our models, has been here far longer than we ever dared to calculate. The structure doesn't break physics. It breaks our version of physics, and the new version hasn't been written yet. If this broke your brain a little, subscribe. We drop one of these every week. Next time. The Fermi paradox has a new answer, and it's far darker than the silence.